Hello dear students, welcome to Royal Palace PU College online classes. Dear students, in the previous session we were discussing about the topic that is properties of definite integrals. Today in this class we shall start with the continue with the problems related to our exercise number 7.11, that is your second last exercise from your integration chapter. Very simple it is. Now before going to that, let us start with the problem. So how we have to solve it, that we shall observe here. Now here given the problem, that is 2 to 8, integral from 2 to 8 mod of x minus 5 dx we have. Now here how we have to solve it, that we shall observe. So before going to that, we have to make use of this particular property, that is integral from a to b, that is a to c and c to a here, c to b. That is nothing but, before starting with that, let us take I is equal to, students. Then by making use of the first year definition, that is mod of x minus 5 equal to x minus 5, when x minus 5 is greater than equal to 0, and then here minus of x minus 5 when x minus 5 is less than 0. Now here the same thing I can write it as, now here the same thing I can write it as x minus 5 when x is greater than equal to here 5 here, and minus of x minus 5 when x is less than 5 here. That means here the point of discontinuity, that is point of discontinuous will be 5 here, that is the point is 5 here, not discontinuous. That means I can interval 2 to 8, I can divide it from 2 to 5 and 5 to 8 here. That means we are having with a property, that is we know that integral from a to b f of x dx equal to integral from a to c f of x dx plus integral from c to b, that is f of x dx. This particular property we can make use here. Now now what we get here, that we shall observe here. Now depending on that, here we have distributed the limit here. Similarly this is our f of x, students, it is nothing but f of x value. This function f of x value, we are distributing from here, that is x is greater than equal to 5, greater than equal to 5 means what it is, from 5 to where, till last is 8 here. This value for 5 is less than 5, less than 5 means where it is, from 2 to 5 here, less than, the least value is 2 here. That means the same I can write as integral from, that is first of all 2 to 5, 2 to 5 x less than 5, that is 2 to 5. What is the function value? Minus of x minus 5 into dx plus of 5 to 8, integral from 5 to 8, very simple problem, 5 to 8. Why? Because x greater than 5, the greatest value here he has provided is 8 here. Now what we get, that is nothing but here x minus 5 into dx. Now easily you can integrate it here, very simple thing. Now if I take here minus sign outside common, that is x integration will be x square by 2 minus 5x between the limit 2 to 5 plus of here x square by 2, x square by 2, minus 5x between the limit 5 to 8, between the limit 5 to 8. Now we shall make use of, integration is completed. Now we shall substitute the upper limit minus the lower limit, which is equal to minus of, now for this integral I will substitute the upper limit. What is the upper limit? That is 25 by 2 minus of, so here 5 5s are 25, upper limit is over. Now you substitute the lower limit, that is nothing but here 2 2s are 4, 4 by 2 minus of, what we have, 5 2s are 10 we have, students, this is over. Next plus of, what is the next part we shall observe here? Now we shall substitute the upper limit, that is nothing but 8 8s are 64 divided by 2 minus of 8 5s are 40, this is for upper limit, minus of, dear students, the lower limit. What is the lower limit? 5 5s are 25 divided by 2, 25 by 2, minus of 5 5s are 25, now we shall close the bracket. Now we shall solve it. So what we have here, 25 by 2 minus 25, I shall keep it as it is, 25 by 2 minus 25. Then here minus 2 ones are 2 2s are, that means 2 we get minus into minus, that is nothing but plus 10, one thing. Then plus of here 64 by 2, that is nothing but here 32 minus 40, then minus here 25 by 2, and here minus into minus, it is plus 25. Now I shall subtract this value by minus here. Before that, okay, before that, what is the value? So now here minus 25 plus 10, that is nothing but minus 10 minus 2. What we get? Minus 15 minus 2, that is nothing but minus 17. Minus of 25 by 2, minus into minus, plus 17. Why? Because here minus 25 plus 10, that is nothing but minus 15. Then minus 2 equal to minus 17. Okay, minus into minus, that is plus here, one thing. Next, plus 1. Now here what we have are 32. Okay, 32 plus 25, that is nothing but here 57. Okay, 57 minus of what we have 40, that is nothing but 17 value. What it is? That is plus 17 here, plus 17. Okay students, and next what we have? That is minus 25 by 2 here, minus 25 by 2. This is what the values we have. Now here we can observe that minus into minus, it becomes plus 25 by 2, and here also it is 25 by 2. That means what is the value here? That is nothing but here 25. Okay, minus 25 plus 17 plus 17, that is nothing but here 34. Okay, now just you can subtract it. Okay, after subtracting, what values we get here? Which is equal to 9 here. That is nothing but your required very simple and easy example. So what we get the value is 9 here. Okay, this is all about the first problem. Now we shall start the next problem. The next question is, okay, so here that is integral from 0 to 1 x into 1 minus x to the power of n into dx, x into 1 minus x whole to the power of n into dx. Now we can make use of this particular example here and how we require to solve it. Hang ಮಾಡಬೇಕಂತ ನೋಡೋಣ ಈಗ. You know what a ಭಾಳ simple problem ಅದ. Let us take this problem as first of all I. Let I is equal to, okay fine, let us take the value as I is equal to. Now here we can observe that I will make use of this property, that is 0 to a f of x dx. Okay, 0 to a f of x dx equal to 0 to a, that is f of a minus x into dx. This particular property I will make use here. So what we get here, that is I will write we know that. Okay, now here which is equal to here 0 to 1. Okay, I can write as 1 minus x. Okay, x means 1 minus x. Now here 1 minus of 1 minus x whole to the power of n into dx. We can take it as the question itself as equation number 1, that is nothing but our I here. Now we shall solve it. 1 minus 1 get eliminates. Okay, minus into minus, plus it remains. So what we have, which is equal to integral from 0 to 1, 1 minus x. Okay, next here 1 minus 1. Okay, 1 minus 1 plus x whole to the power of n into dx, which is equal to integral from 0 to 1, 1 minus x into x to the power of n into dx. Now here what we can do here is multiply by x to the power of n. There is integral from 0 to 1, x to the power of n minus x to the power of n plus 1 into dx. Now dear students, easily you can integrate it. Now integration formula we will make use. That is nothing but here x raised to n formula is x raised to n plus 1 divided by n plus 1 minus of x to the power of n plus 1. That means x to the power of n plus 1 whole divided by n plus 1 plus 1. Now what we have between the limits, okay, dear students, before going to that, between the limits what we have here, 0 to 1 here, between the limits 0 to 1. Now easily you can substitute the limit value. So what we have for the upper limit, dear students, for the upper limit, that is 1. 1 raised to anything, that is 1 only, n plus 1. Here also 1 to the power, that is 1 only, minus 1 divided by n plus 2. Minus of lower limit, x, 0. 0 becomes 0 minus 0 here. No need to substitute. Now here you can take the LCM here. What we get here, which is equal to 1 divided by n plus 1 minus of 1 divided by n plus 2. What we have here, okay, now we can take the LCM, that is nothing but here n plus 2 minus of n minus 1 divided by n plus 1 into n plus 2. Here we can observe that n get eliminates, 2 minus 1 that is 1. The remaining part is n plus 1 into n plus 2. That is nothing but your required result. Okay, dear students, these are the two problems related to our exercise number 7.11. Now we shall continue with our problems related to this. So before going to that, please pause the video to note it down. Okay, dear students, now let us continue with the problems related to our next part. Now what we have? We are having 0 to pi by 4 log of 1 plus tan x. Very simple thing. So now what I will do is, let us take I is equal to the required question, that is integral from 0 to pi by 4. We are having log of 1 plus tan x, okay, whole to the into dx we have, okay, into dx. Next thing, this is the first part. The next thing will be, okay, so now here I will make use of the property. Which property? We know that integral from 0 to a f of x dx equal to integral from 0 to a f of a minus x into dx, f of a minus x into dx. Now here, dear students, we can observe that we are having pi by 4, that I will substitute, that is I is equal to integral from 0 to pi by 4, okay, pi by 4, then what we have, log of 1 plus tan of pi by 4 minus x, tan of pi by 4 minus x into dx. Now here tan of pi by 4 minus x we have, that is tan a minus b formula we will use. Tan of a minus b means what? Tan a minus tan b, which is equal to integral from 0 to pi by 4, students, that is we have log of 1 plus, here I can write as tan of pi by 4 minus of tan x whole divided by 1 plus tan of pi by 4 into tan x into dx. Now you can take the LCM here. Okay, students, you can take the LCM here. What we get? Tan pi by 4 value will be 1 here, which is equal to integral from 0 to pi by 4. We are having, okay, log of 1 plus tan pi by 4 value is 1 into tan x divided by 1 plus tan x into dx. Now here you can take the LCM here, that is 1 plus tan x plus of this value, which is equal to integral from 0 to pi by 4, okay, log of 1 means what it is, multiplied by here 1 plus tan x, 1 plus tan x, okay, plus of 1 minus tan x whole divided by what we have, students, that is 1 plus tan x, okay, 1 plus tan x into dx. Now here we can observe that here tan x get eliminates, 1 plus 1 the value will be 2, that is 0 to pi by 4, what we get here, log of 2 divided by 1 plus tan x into dx. Now you can make use of logarithm property. What it is? Log a by b means what we have? Log a minus log b. That property now use ಮಾಡಬಹುದು. ಅಂದ್ರೆ ಏನು ಬರುತ್ತೆ ನೋಡ್ರಿ, that is integral from 0 to pi by 4. Okay, what we have, that is log of 2 minus log of what we have, that is 1 plus tan x, 1 plus tan x into dx here. Okay, this is first thing. Now I will separate the integral value. So what we get, which is equal to integral from 0 to pi by 4. Now what is the LHS part? I here, that is log 2 minus integral from 0 to pi by 4. We are having log of 1 plus tan x into dx. Now we can observe that according to the equation number 1, that is the given question, okay, this value will be I here. So which is equal to I is equal to 0 to pi by 4, that is log 2 dx minus I. If I take I here, I plus I, the value will be 2I equal to, if I take log 2 constant outside, integral of dx, that is from 0 to pi by 4. Okay, so now what we have, that is nothing but here log 2, okay, log 2 into, okay, now here one integration will be x, that is from what it is, from 0 to pi by 4. Okay, now here I can substitute the limits here, that is nothing but here 2I is equal to, okay, log 2 I will keep as it is. Okay, now here pi by 4 minus 0 here, what we get, divided by 2, that is I is equal to log 2 pi by what we have, 8, okay, which is equal to pi by 8 into log 2. That is nothing but your required very simple example. Okay, dear students, it may be asked for your 2 marks. Okay, in the examination, very, very small problems will be asked. Okay, not too much lengthy problems will be asked in your examination. Okay, now let us move on to the next problem. The next problem is integration from what we have, that is 0 to 2, okay, x into root of 2 minus x into dx. Here also we have to make use of the same property only. Okay, the same property we have to make use here. What is that property? That is 0 to a f of a minus x dx. The same property we have to make use here. Okay, that is, let us take the question as I is equal to integral from 0 to 2 x into 2 minus x dx. Now here I can rewrite it as integral from 0 to 2, okay, 2 minus x into 2 minus of 2 minus x into dx, because write down the property 0 to a f of x equal to 0 to a f of a minus x dx. Now, so now here what we can write here, I will substitute it. So what we have, I is equal to integral from 0 to 2, that is a 2 minus x, okay, 2 minus x, 2 to get eliminates, what is the remaining part? Okay, it is not root here, it is bracket root x. Okay, you can take it as into dx, I can write here. Now here what I can observe here, I will multiply it by root here. So what we get here, 0 to 2, 2 root x, or else root x can write it as x to the power of 1 by 2 here, okay, minus x into x to the power of 1 by 2 into dx, which is equal to integral from 0 to 2, 2 into x to the power of 1 by 2 minus x to the power of 1 into x to the power of 1 by 2, that is x to the power of 3 by 2 into dx. Now here I will integrate it. Okay. Now what is integration of x raised to 1 by 2? That is x raised to 3 by 2 divided by 3 by 2 minus of x to the power of 5 by 2 divided by 5 by 2 between the limit 0 to 2 here. Now I will take the constant here. So what we have, that is 4 by 3 x to the power of 3 by 2 minus of 2 by 5 x to the power of 5 by 2, 0 to 2. Now you can take out the value common. So what it is, now substitute the upper limit. What is the upper limit value here? Okay, the upper limit value is 2, that is 4 by 3, that is 2 to the power of 3 by 2 minus of 2 by 5, then we have 2 to the power of 5 by 2, one thing, minus of lower limit value will be 0 only. Okay, after substituting it, okay, 3 by 2, that is nothing but I can write 2 root 2. Here I can write it as 2 square into root 2 I can write. Okay, 2 square means it is 4. 4 into root 2 I can write here. In that manner I can write here. So after solving it, ultimately you will get the last answer as 16 into root 2 divided by, okay, 15. Okay, why? Because here 5 3s are 15, the LCM will be 15. Dear students, you can, it is quite simple, you can calculate it and write down the answer here. Okay, dear students, now please pause the video to note it down so that we can move to the next problems. Okay, dear students, now let us continue with the next problem. Now here in this next problem, what we have the limits, that is minus pi to pi. Okay, we are knowing on property. What is that? The property is integral from minus a to a. Okay, what is that? F of x, the value will be 2 into 0 to a, that is f of x. Okay, what it is, the limit is when f of minus x equal to f of x, one thing. Okay, and its value is 0 when f of minus x equal to minus f of x. Okay, this is the value here. Now this is one thing. Now here, because here f of minus x equal to f of x and f of minus x equal to minus f of x, these two conditions we have to check. Those are nothing but our even and odd functions. Those are nothing but even and odd function. It is an even function and it is an odd function. I can write as even, like even, and it is nothing but odd here according to the property. That is nothing but our function depending on the function here. That means here what we have here, f of x means what we have, that is nothing but here sin square x here. Okay, and here we can observe that if it is only from minus a to a, not 0 to a, that another property we are having. So here f of minus x equal to, that is what we have, that is sin square of minus x. Now what is the value for sin of minus theta, that is minus sin theta. that is minus sin x whole square, that is nothing but here sin square x, okay, sin square x. Now here f of minus x equal to what is the value we get, that is f of x equal to f of minus x equal to f of x we got here. Now that means it is an even. Even means what it is formula, that implies here integral from 0 to pi by 2 to pi by 2 we are having sin square x dx, which is equal to 0 to pi by 2, that is 2 into 0 to pi by 2 we can write as sin square x dx, okay, sin square x dx. Now easily you can integrate it, okay, easily you can integrate it and find out the value here. Now how to find out this particular value, already in the previous class we had seen about it, that is in the place of x what you can substitute, pi by 2 minus x, in that manner we can solve it. Now let us take it as here, now here which is equal to 2 into 0 to pi by 2, here sin square of pi by 2 minus x again, right, into dx. So which is equal to 0 to pi by 2, we are having here sin square means it becomes here cos square, pi by 2 means cos square of x dx, okay. You can take this value as equation 1 and this as equation number 2, and I can write as, let us take I is equal to, okay, 1 plus 2 if I do here, 1 plus 2, that is nothing but I plus I means 2I, integral from 0 to pi by 2, what we have cos square x dx, plus integral from 0 to pi by 2 we are having sin square x dx. After we can observe that the integrals are same here, integral same ಇರೋದ್ರಿಂದ ಆ ಫಂಕ್ಷನ್ ಏನು ಮಾಡ್ಕೋಬಹುದು, ನಾವಿಲ್ಲಿ ಆ್ಯಡ್ ಮಾಡ್ಕೋಬಹುದು, that is nothing but here cos square x plus what we have sin square x into dx. Now here sin square plus cos square x value is 1 here, so here it is 2, okay, 2 is the remaining part, dear students, okay, here 2 is there. I can take 2 into integral of that thing common, that means here 2 into integral of 0 to pi by 2 1 dx, okay, because sin square x plus cos square x value will be 1 here, that is nothing but here 2I is equal to 2 into x here, integration of 1 is x 0 to pi by 2 which is equal to 2 into pi by 2 minus 0. Now here we can observe that here 2I is equal to 2 into pi by 2, 2 to get elements, the answer is pi by 2, the value will be pi by 2, very very simple answer here, okay dear students. Now let us start with the next question, okay. The next question is very simple, that is integral from minus pi by 2 to pi by 2 we are having 7 raised to x into dx, okay, sin raised to 7x into dx. Now again we are having from minus a to a, again this particular property we will make use here. That means here when here f of x means what we have, f of x is equal to we are having sin raised to 7x, okay. Now here that implies f of minus x equal to what we have, sin to the power of minus x, okay, that is sin to the power of minus 7, okay, that is minus x. Now what is the value for sin of minus theta, that is nothing but minus sin x whole to the power of 7, that is minus of what we have 7 raised to x, that is nothing but here minus of f of x. That means what we got, f of minus x equal to minus f of x, it is an odd function. Odd function means what is the function value directly here, it is 0 here, very very simple question. Now that implies, okay, what we have, that is minus pi by 2 to pi by 2, that is sin raised to 7x dx, the value will be 0, and because you can write on the property here, property 6, the last property, okay. So the last property, that is this particular property, by making use of this the value will be 0. Dear students, these type of questions is also very very important for your KCET level, okay. KCET level these problems are very very important. Why? Because within few steps only you can get down the answer, and no need to find, and no need to by looking onto the problem, if it is sin to the power of odd numbers, okay, sin to the power of odd numbers, that means always it is an odd function only, okay. Similarly we can find out the values here, okay dear students. Now let us move on with the next question. The next question is, now we shall take another problem, that is 0 to 2 pi, what we have, cos to the power of phi x into dx. cos to the power of phi into dx. Before this, this is a property 6 here. Before this, we are started with the property 5th here. What was that property? The property states that is integral from 0 to 2 pi, okay, integral from 0 to 2 pi f of x dx, which is equal to, okay, 2 into integral from 0 to pi f of x dx. When it is only when it is an even like. What do you mean by even like here? Even like, that is nothing but here f of 2 pi minus x equal to f of x. Okay, this is the condition, and it is 0. The value will be 0 when f of 2 pi minus x equal to minus f of x. That is odd like. It is odd and it is even. When it is, whenever the interval is 0 to 2 pi, interval is 0 to 2 pi means or 0 to 2a. Okay, here I can write in general that is 2a interval. Okay, in general that is the derivation, that is 2a only. I will take here 2a. Okay. Now here f of 2a minus x equal to minus f of x means it is odd and the value will be 0 here. Now here what is the f of x here? F of x is cos to the power of phi x, cos raised to phi x here. Here f of x equal to value we have cos to the power of phi x. But now here what we have to do is we have to check for even. We have to observe very clearly that in the place of x, what we have to substitute? 2a minus x, that is limit here. Limit what we have? 2 pi. So what we have to substitute here? F of 2 pi minus x equal to, now in the place of x, only wherever you are having x, not in the constant, okay, only in the variable. What is the variable here? That is cos to the power of x, that is nothing but 2 pi minus x. Now here, can I write it as cos of 2 pi minus x whole to the power of phi here? Now what is the value for cos of 2 pi minus x? Now here cos of 2 pi minus x, in which quadrant does it comes? Okay, so here we can observe that it is 2 pi, okay, 2 pi, here it is plus 1, okay, here it is plus and it is will be minus here. That means cos of 2 pi minus x comes in the 4th quadrant. According to the ASTC rule, all are positive, sine and cosecant are positive, tan and cot are positive, cos and secant are positive. That means here cos, what it is? Cos value is the positive, okay, cos value is positive here, and here cos remains as it is. What is the value? Cos remains as it is. Next thing is just directly you can write the value for cos to the power of, okay, cos to the power of phi x, okay, cos to the power of phi x value, and that in turn that is nothing but our what it is? F of x. That means what we have? F of 2 pi minus x, okay, f of 2 pi minus x equal to what we have? F of x. That means what is the function here? It is the function will be even like. Even like means what it is? 0 to a here. What we can apply here? 0 2 into 0 to a, f of x dx you can apply and you can solve it. Very, very simple example here. Now that implies what we can write here, that is 0 to what we have here? 2 pi. Now here f of x cos raised to phi x dx equal to, okay, that is I is equal to, the value will be integral from 0 to pi cos raised to phi x into dx. Now easily you can solve it. How we have to solve this? That is, you can take it as cos square into cos cube. Cos square into cos cube, you can make use of trigonometric formulas, okay, and then you can, okay, apply the integral formulas and you can substitute both upper limit and the lower limit values here, and that manner you can solve the values here. Okay, dear students, it was a very, very simple problem related to our exercise number 7.11 students. So dear students, by here all the examples related to our properties of definite integrals, okay, are over. That means in the examination, as far as your examination point of view, dear students, okay, always in the examination, that is in Karnataka State PU Board, question number 49A, okay, A, it will be of 6 marks. This particular 6 marks will be here 4 plus 2. This 4 marks will be one among your derivation. What derivation is? These all properties we had seen, 6 properties are there. One among this property, especially from 3rd, 4th, 5th, 6th, especially these 4 properties are very important. And along with that property, okay, for example, here if this derivation will be asked, simple problem according to that, Okay, simple problem according to that property, it will be asked for 2 marks. Okay, dear students, that means this topic is a very simple one, and you can easily score by making use of this particular properties of definite integrals. Okay, dear students, in the next class we shall start with the miscellaneous exercise related to this particular topic. Till that, thank you.